Okay, this video is about intervals of increase and decrease in functions. And so, how you can tell where a function is increasing and decreasing, you pretend like you're just riding the curve, like you're on a ride at Disney World or something. So if you were riding, let's look at number 1, and I know this worksheet is a little confusing the way I have it spaced. So number 1 and number 2 go with the top set of instructions, which says determine the intervals on which the function is increasing, decreasing, or is constant. So increasing simply means where the function is going up, increasing. Decreasing simply means where the function is going down, decreasing. And constant means where it's going the same. You'll see some horizontal part of the function when it's constant. So, how do you answer that? Whenever they ask where is the function increasing or decreasing or constant, you answer with x values. Where in math means x values. What in math means y values. So that's something that we want to learn how to connect in our brain about that. So for number 1, where is this function decreasing? Well, right here, this part of the graph, it's going downhill. So this is where it's decreasing. Right here, this part of the graph is where it's increasing, and this part of the graph is where it's staying the same. Sometimes I find it helpful to actually draw an arrow right here. This is going downhill, this is going uphill, and this is remaining the same. So this, between here and here, is where it is decreasing. For what x value? So then you have to look carefully at your graph and call out the x values where that is happening. When I looked at it, it looked to me like this point right here is for x, it's decreasing when x is -5 all the way to this point where x is 1. Where is it increasing? Well, it's increasing from where x is 1 to where x is 3. And then it's constant from where x is 3 to where x is 5. Now, why am I using parentheses? Because that is always acceptable when you are writing down intervals of increase and decrease. I have seen occasion where textbooks might put a bracket on one, but I don't particularly agree with that. Maybe there's some special cases it's okay. But for instance, look at number 1. Look at the x value 1. Do you see this? My question is, well, brackets mean it belongs. It's contained in that set. Does the value 1, is it increasing or decreasing when x is 1? Well, it's doing both, right? It's decreasing at 1, and then it starts to increasing. So 1 does not belong to either group. That's why I use parentheses right there. Also, look at 3. 3 is transitioning from it's increasing and then it goes constant. Does 3 belong to the increase side or the constant side? Neither one. 3, that's why I use parentheses there. So if you were wondering about that, that's what I do. Let's go ahead and call out the domain and range for this for practice. The domain of this function is the x values. How far to the left does this guy go? -5. How far to the right does this guy go? +5. All right, what is the lowest value that we see? Let's call it the ranges. The lowest value that I see here is +1, and the highest value that I see is 4. So this would be the domain and range. Why am I using brackets? Because those are closed circle, it's included in that group. All right, let's do number 2. Where is this function increasing? Increasing, what are the intervals? Where is it decreasing? And are there any constant intervals? Now, just so you know, a function is not obligated to have an increase, decrease, and constant interval. It doesn't have to have all 3. Some functions are always constant. Some are always increasing. Some are always decreasing. Some have 2 categories. There's no, like, you don't have to have all of them at all. So right here, let's look at this guy. Right here, it's staying the same. It's constant during this part. So let's go ahead and name the constant part. It starts at what x value? You see that arrow? It starts at -infinity. So it's going to be constant from x is -infinity all the way to this x value. And that looked to me like it was -1. All right, that's the constant part. Then let's see what's happening here. Then it's decreasing here, right? Then it's increasing here. And then it's decreasing here. So let's talk about from here to here, it's going down. So this x value is -1. It's decreasing from -1 all the way to this x value, which is +1. Remember, we're only writing down the x values. And then it starts to increase. So we don't want to include that in the decrease category, but then it decreases again once it gets to this part. What x value does that happen at? At x is 4. So we want to say union, which means let's add on to the set from 4 to infinity. That's the decreasing part of this graph. Now, was there an increase part? There sure was, right here, from here to here. So let's talk about where it's increasing. It's increasing from x is 1 till x is 4. That's the increased part of this graph. Now, let's talk about the domain and the range of this graph. So, what is the domain? You ask yourself, how far to the left will this function go? And do you see that arrow? It's going to start way over at -infinity. So it's coming in from -infinity, and when it gets to this point, it jumps. But the fact that this is a closed circle means it's defined there. So that's fine. The second it gets past this, it's defined in this red. It's defined, it's defined. So the domain is actually all real numbers, and so this is how you write that in interval notation. And the range is the lowest value to the highest value. You see this arrow? It's going down as low as it wants to go. So that is born basically at -infinity, and it's going up, and the highest point that we get to is up here. And that, to me, it starts at -infinity and it goes all the way up to this point, and that looks like 11 to me. And it's defined, so you get a bracket right there. All right, now, this is where the worksheet's a little confusing. That was for 1 and 2. Number 3 has a different set of instructions. They're similar, but it says, using the graph, determine any relative maxima or minima of the function in the intervals on which the function is increasing or decreasing. Okay, so let's go ahead, let's look at this guy. Let's talk about its domain and range. The domain is as far to the left as it wants to go and as far to the right as it wants to go. So the domain is all reals. What is the range? Well, it starts, this arrow, it's from -infinity, and you see this arrow, it's to +infinity. So domain and range are a little boring, all reals. -infinity to +infinity, -infinity to +infinity. Okay, that's that. Now let's talk about what we just got through doing. How about the domain, the intervals of increase and decrease? Well, look here, if I'm writing this curve, I'm going downhill right here, so that I'm decreasing here. This is a decrease. Then I have an increase, and then I have another decrease. So where is it decreasing and where is it increasing? That's the question. It's decreasing from x is -infinity all the way to this point. And so this point, I put it in the wrong spot. I put it at the x values, but really it's supposed to be here. Let me redraw my graph a little bit. Okay. So this point is really it almost looks like 0, but 0.103. So it's decreasing from here to this point, -infinity to 0.103. And then it starts to increase. Where does it start to increase from? 0.103 all the way to this point. And so what's the x value there is 3.601. And then it starts to decrease again. So where does it start to decrease? It starts to decrease at 3.601 till infinity. Notice I did not write down any y values, because that's not what you write down when they say where does something increase or decrease. For what interval does it increase or decrease? You only write down x values. Now, when they ask about a relative minimum or a relative maximum, they are interested in knowing the values of those, and that involves the y values. So right here, we have this little scoop down, and we have a scoop up. A relative minimum means a low place in the graph. So the relative minimum can also be referred to as a local minimum. And what it means is in the general area, in the local area. What's the low point there? Not the absolutely lowest point that the graph achieves, because look how far down this is going. -infinity. That is not a local minimum. That is how far low as it's going to go. Local minimum means in the general area. So right here, here's one. And so when they say, what is the local or relative min? if they use the word what, and that's what I will use with you to teach you how this language works, what is the local min? Then you write down the y value. The local min is 0.995. If I were to say what is the local max, this word what, that means talk about the y value. So here, a maximum is, in general, a high place. Do you see somewhere where it's high relative to everything else in the area? This is a relative min or a local, relative max or local max. It's not the absolutely max because see how high it's going to go as far as it wants to go. But in the general area, this is a high place. So it's like a hill. And so what is the value of this? You put 2.921. So when they use the what language, that's what they mean. So if they were to say, where does the min occur? If they said, where does the min occur? Where, and I'm just going to shorten it, where is the local min? When they use where language, that's X language, you would say at X equals to 0.103 or just 0.103. If they said where is the local max or relative max, you would say at 3.601. The local, where is the local max? Yeah, you would say at 3.601. Or you'd say at X equals 3.601. Okay, so where language is X values, what language is Y values. Now, let's do number 4. Number 4, it says, graph this function. Estimate the intervals on which the function is increasing, decreasing, and if there's any relative maxima or minima. So, let us just do a little bit of point plotting. I'm going to pick some X values for you so we know some ones to look at. How about this? Let us do -5, -4, -3, -2, -1. And so I picked these specially because I'm a little bit familiar with these graphs. And so you could do 0, -2, -1, 0, 1, 2 like I did on the last time, but it wouldn't show us as much as we want to see here. This is kind of the special part. So let's put a -5, see what happens. Okay. -5 plus 3 is -2. The absolute value of -2 is 2. 2 minus 5, we're going to get a -3. Okay. -4 plus 3 is -1. The absolute value of -1 is 1. Minus 5 is -4. Okay. -3 plus 3 is 0. 0 minus 5 is -5. -2 plus 3 is 2. The absolute value of 2 is 2. Minus 5 is -3. -1 plus 3 is 2. Absolute value of 2 is 2. Minus 5 is negative. No, sorry. Yeah, negative. Wait, am I doing wrong? 2 minus 5 is -3. Did I do something wrong here? Oh, -2 plus 3 is 1. 1 minus 5 is -4. That's what went wrong there. Okay. Now I have a few points. These are my points. X is -5. Y is -3. X is -4. -4. -3, -5, -2, -4, -1, -3. Okay, so let us plot this. I'm over here at -5, 1, 2, 3, 4, 5, and I'm down at -1, -2, -3. I am down here. At -4, -4. I'm at -4. I'm going to be down here at -4. A little bit lower. Okay. At -3, at -1, -2, -3, -4, -5. At -3, I'm down at -1, 2, 3, 4, 5. I'm down here. At -2, I'm up at -4. And at -1, I'm up at -2. Is that right? No, -3. This should be here. This should be here. Okay. Oh, goodness, it's not really. All right, that should look kind of like that. Okay, so you get these points. This is an absolute value graph, and like I discussed in the last video, you connect them like with harsh lines, with V shape. So this is the V shape that we will get for this graph. So that's how we can plot it. Now we need to talk about What is the domain? I'll just mention that real quick, from negative infinity to positive infinity. What is the range? The lowest point that this thing achieves right here, 1, 2, 3, 4, is -5. The range would be from bracket -5 to infinity. But that's not what they asked us here. They said, tell me about increase, decrease, relative max or min. This function is decreasing. It's going downhill from over here, from the moment it's born, at x is negative infinity, all the way to x is this value. So this point right here is -3, -5. So where is it decreasing? From x is negative infinity to x is -3. That's where it's going down. Where is it increasing? From this point and beyond. So it's increasing from -3 to infinity. That's where it's going to increase. Now, what does it have a relative max? No, it does not. Does it have a relative min? Yes, it does. It has a low point in the general area. So what is the lowest point? And in this case, the relative min is also the absolute min. But what is the relative min? So we could just say there's no relative max or no local max. But there is a relative min at x equals -3, and with a value of -5, or y equals -5. So that's that kind of language I want you guys to learn how to use and talk. All right, I'll make sure you got that on there. Okay, cool.